Hello students, today we discuss drift velocity and relaxation time. We have many free electrons in metals. Nearly around 10 raised to 28 free electrons are there in a cubic meter. At room temperature, all these electrons are random in motion. There is no preferred direction for this electron. On an average, the number of electrons traveling in a particular direction will be equal to the number of electrons traveling in opposite directions. If you are calculating the average velocity of electron in this metal, it will be equal to 0. If U1, U2, etc. Un are the velocities of n electron. They are vector quantity. U1 is the velocity of first electron, U2 is the velocity of second electron, etc. Un is the velocity of nth electron. So if you are calculating the average velocity, you can write the average velocity is equal to U average is equal to U1 plus U2 plus U3 plus etc. up to Un by n. It is the average velocity of all electron. It is equal to 0 because they are random in motion. There is no preferred direction. On average, the number of electrons traveling in a particular direction will be equal to the number of electrons traveling in opposite direction. So by using the vector concept, if you are adding their velocity, the average velocity of all electron will be equal to 0. That is U1 plus U2 plus etc. up to Un by n is equal to 0. The average velocity of all electron in a metallic conductor due to their thermal motion is equal to 0. Even individual velocity of the electron is very high. It is in the order of 10 raised to 5 meter per second. But the average thermal velocity of all the electron will be equal to 0. That is U average is equal to 0. Now, if you are applying an external electric field to this metallic conductor, under the presence of external electric field, all the electrons experience a force. If we are applying an electric field E is applied to this conductor, so we can say all the electrons experience a force F is equal to E into E. All the electrons experience a force F is equal to, we can write as vector form, F is equal to E into E. As this force is just opposite direction of electric field, you can write as the force experienced for the electron is equal to, for one electron is equal to F is equal to the magnitude of charge into strength of electric field. F is equal to Q into E. So we are writing the charge as E minus E into capital E, electric field. This minus sign shows that the force is just opposite direction of the electric field. All the electrons experience this force just opposite direction of this electric field. Once a force is acted on an electron, it have an acceleration. So we can write the acceleration for one electron is equal to, acceleration A is equal to force by mass. We can write as the force by mass, the magnitude of force by mass. That's equal to force on one electron is equal to minus E by m. So we can say under the presence of an external electric field, all the electrons are getting accelerated. But this gain in velocity can retain in a very small time interval. That is, after getting accelerated, each electrons collide with the positively charged ions, that is the positively charged ions present in this conductor. or in with some other electrons. But after every collision, it's lost its acceleration. That is, the additional velocity gained by the electrons lost after every collisions. And after every collisions, each electron start afresh with a random thermal velocity. After every collision, they lost their velocity gained and they start afresh with a random thermal velocity. Now, suppose an electron having a random thermal velocity, one of the electron having a random thermal velocity u1. u1 is the random thermal velocity of one electron, and it accelerating for a very small time interval, say tau 1. Tau 1 is a very small time interval. Okay, that is the time interval before it colliding with the next electron or ion. That is very small time interval. Usually it will be very small, in the order of 10 raised to minus 15 second. The time interval between any two collision. Tau 1 is the time taken for this collision. So it having an acceleration a is equal to minus e by m. So we can say it gain a velocity. What is the velocity gained by that electron? The velocity gained by that electron can be write as v1. v1 is equal to its initial velocity is u1, and it accelerate for a very small time interval tau 1. So we can write as a into tau 1. Remember our equation of motion, v is equal to, using this equation, v is equal to u plus at. v is equal to u plus at. For a uniform accelerated motion, the final velocity is equal to initial velocity plus acceleration into time. Here the final velocity v1, vector v1 is equal to initial velocity u1, vector u1 plus a into tau 1. A is also vector quantity. Now substitute for this acceleration. Before that, we can write the velocity vector for the any other electron like this way. v2, suppose the velocity of any other electron v2, the second electron v2 is equal to what? u2 plus acceleration into relaxation time. Suppose its relaxation time is equal to tau 2. Similarly, we can write the velocity of nth electron, the velocity gained by the nth electron is equal to Vn is equal to Un plus a into its relaxation time. Say it is Tn. Now we calculating what is the average velocity gained by the electron under the presence of external electric field. So that we can write as, that's v is equal to v1, the total velocity, average velocity. V is equal to v1 plus v2 plus v3 plus etc. up to vn by the number of electrons. Say n is the total number. So average velocity is equal to v average is equal to v1 plus v2 plus v3 plus etc. up to vn by n. Now substitute this value. What is v1? v1 is equal to what? v1 is equal to u1 plus a into t. That is u1 plus a into t, tau 1, relaxation time tau 1, plus what is v2? v2 is equal to u2 plus a into tau 2 plus etc. right for the nth electron by the number of electron, is n. Now we can rearrange that equation. V average is equal to average velocity is equal to, rearrange that equation as u1. We are first writing u1 plus u2 plus etc. We have up to n electron are there by n. by n plus a into, we are taking acceleration as common, a into, we have that tau 1 plus tau 2 plus up to n electrons are there, that is tau n by n by n. So V average is equal to U1 plus U2 plus etc. up to Un by n plus A into tau 1 plus tau 2 plus etc. up to tau n by n. What is this term? U1 plus U2 plus etc. up to Un by n. It is the average thermal velocity. We already know that the average thermal velocity of all electron is equal to 0. Average thermal velocity of all electron is equal to 0. And what is this term? Tau 1 plus tau 2 plus etc. up to tau n by n. Tau 1 is the time taken for the collision for the first electron. After acceleration, what's the time interval between any two collision? Tau 2, the time taken by the second electron before collision. So we can say it is the average time interval between any two successive collision. This tau 1 plus tau 2 etc. up to tau n by n, it is the average time interval between any two successive collision, and that term is known as the relaxation time. The relaxation time. Relaxation time is defined as the average time interval between any two successive collision, and it is very small. Usually it is in the order of relaxation time will be in the order of 10 raised to 14 minus 14 second. Relaxation time will be in the order of approximately 10 raised to minus 14 second. It is too small. So we rewriting this equation, the average velocity is equal to the first term, average thermal velocity is equal to 0, 0 plus a into we can write as this term is the average relaxation time, that is equal to tau. We are writing average relaxation time, that is equal to tau. Now, what is the average velocity that gone? The average velocity is equal to V average is equal to A into relaxation time. The vector A into relaxation time. Substitute for what is acceleration. Acceleration is equal to minus E by m. This is the acceleration. So substitute for acceleration. That's equal to average velocity is equal to V average is equal to minus E by m into relaxation time. Average velocity is equal to minus E by m into relaxation time. What are these terms? This is the average velocity gained by the electron because of the presence of external electric field, and E is the charge of electron, E is the strength of electric field, tau is the relaxation time, average time interval between any two successive collision of electron, and m is the mass of electron. So this velocity is the additional velocity gained by the electron, just opposite direction of this electric field. It have already a velocity that having a thermal velocity. Random thermal velocity is already there. It is very high in the order of 10 raised to 5 meter per second. In addition to that velocity, all the electrons gain a very small velocity in a particular direction, in a specified direction, and that velocity is known as the drift velocity. This velocity is known as what? Drift velocity. Drift velocity. So this is the expression for this drift velocity, average velocity gained due to the electric field, gained due to the presence of external electric field. Drift velocity is equal to minus E by m into relaxation time. This is the additional velocity other than the thermal velocity, and drift velocity is equal to minus E by m into relaxation time. It may be noted that electrons getting accelerated under the presence of electric field between any two collisions, but on average the net acceleration for the electron is zero. It is because of all the electrons are continuously collide each other or collide with the metal ions present in the metals, or all the electrons are moving without any acceleration with a very small velocity, that is drift velocity. It is in the order of 10 raised to minus 5 meter per second in opposite direction of the external electric field. This motion of electrons can be compared to the falling of a metallic ball. Suppose we have a staircase like this. A metallic ball is falling through this staircase. Once it's fall from one stair to the other stair, it's falling under gravity. So it get accelerated. But when it collide with the next stair, it lost whatever the energy gained. Due to the falling, it getting accelerated under gravity, and due to the next collision it lost whatever the energy it gained, and again it's rolling with a constant velocity, and when it falls to the next stair again it getting accelerated. So this is the process actually happening in the conductor also. When the electrons are accelerated, it collide with the next electron or metals, and they lost whatever the energy they gained, and all the electrons having a very small velocity just opposite direction of this electric field, and that very small velocity is known as drift velocity. It having two velocity, actually all the electrons having two velocity. They have a random thermal velocity. It is very high in the order of 10 raised to 5 meter per second. In addition to that velocity, it having a very small velocity known as drift velocity. It is too small. Usually it is in the order of 10 raised to minus 5 meter per second, just opposite direction of this electric field. This is the expression for that drift velocity. V average is equal to, drift velocity is equal to minus E by m into tau, and this minus sign shows that electric field and drift velocity are in opposite direction. Thank you.